Okay, so everyone's talking about it, right? Like the next big thing, this tech revolution that's brewing. And you keep hearing AI, artificial intelligence, everywhere you turn. But it's the data. That's the real story here. The sheer volume of information these systems can handle. It's mind-boggling. We're talking about data sets so massive that no human team could ever make sense of it all on their own.
Yeah, it's a whole different scale now. We're talking about a shift so fundamental that it requires a whole new kind of intelligence. An intelligence that can sift through it all, analyze it, make sense of it.
So that's what we're diving into today. The state of AI right now, the breakers, the possibilities, the big questions being asked, especially by the people on the front lines of this field, the researchers, the scientists.
That's exactly right. We've gone through some fascinating stuff, actually, including this VCE news report with some leading AI experts, people from places like Stanford, NASA, Berkeley, even Oxford.
So our mission today, it's pretty simply, is to get past the hype, to see what's really going on. What are the big discoveries? What could they mean for our future? And what are the potential downsides? The things that even the experts are worried about.
It's about recognizing the potential, absolutely, but also being aware of the real concerns, the questions we need to be asking about where all of this is taking us.
So let's start with where we are now, with AI. It feels like you can't get away from it.
Right.
In our phones, in our cars, in entertainment and security systems, even in our homes now.
No question about it. And a lot of this is because of some big leaps forward in AI. One of the biggest being deep learning.
Deep learning. Can you break that down for us a little bit? What exactly is it? What makes it so important?
Basically, it's a way for AI to learn, to find complex patterns in huge amounts of data. A good example is how well AI can recognize images now. Like just a few years ago, if you had an AI trying to identify 1,000 different things, it might only get 5% right. Now the best ones are getting like 98%. And it's not just the number, it's what it means. AI can now actually see the world in a way machines never could before. That opens up so many possibilities.
5% to 98% in just a few years. That's incredible. But okay, so it can recognize a cat in a picture. What does that have to do with, real world stuff?
Well, think about this project at Stanford. They're working on this robot called Jack Ribbit. It's designed to move through crowds. What's amazing is they didn't program it with every rule, every situation it might encounter. Instead, it learned by watching people.
So if it watched how people in crowds move around each other and figured out the unwritten rules?
Exactly. It filmed crowds from above for 2 months. Jack Ribbit analyzed all that footage, how people move, how far apart they stay, when they speed up or slow down, and how it can navigate all on its own. Avoid running into things. They even said it's better at this than some self-driving cars.
Wow, so it just rolls around, figuring out how to avoid people in real time, no joystick, no remote control?
Nope, totally autonomous mode. Its main job is to not hit anything. Give it a basic map of the area, and it can go from point A to point B. Dodging whatever gets in its way, it uses sensors to understand its surroundings, even tries to predict where people are going to move next. It's interesting, people's first reaction wasn't fear, but curiosity. Some even tried to hug it, so that gives you an idea of where we are with AI now, learning from data to do specific things. But then you had these supercomputers, like the ones NASA uses. They're on a whole other level.
Oh yeah, tell me about that.
Well, Brian Beagley from NASA's Advanced Supercomputing Division gave this great example. Their ocean simulation. They use tons of data from their satellites to actually predict how the ocean's going to behave decades into the future.
Decades? That's mind-blowing. But how does that could a raw power compare to the AI we've been talking about?
The scale is just insane. This one simulation used up to 70,000 processors, and it generated over 3 petabytes of data. That's like 10,000 times what your fancy laptop can hold. You can see ice cracking in Antarctica, ripples spreading across the ocean. But here's the key difference. This simulation, as amazing as it is, it's all based on code, programmed code. Every single line was written by humans, over 15 years.
So it's incredibly powerful, but it's basically just following instructions. It doesn't learn and adapt like Jack Ribbit does.
You got it. And that brings us to what true artificial intelligence could be. The real leap is when the system can evolve, can learn in ways that even its creators don't fully understand. That's what people call the black box aspect. That term black box, it refers to systems where, sure, we understand the initial code, but the learning, the decisions the AI makes, they become kind of a mystery. But the inner workings, we can't see them clearly anymore.
A black box. So we set it up, and then it starts doing things, developing abilities that we didn't specifically plan for. There's an element of the unknown there, right?
Absolutely. The structure of these advanced AI systems is often inspired by the human brain, that incredibly complex network of neurons. Deep learning networks, they try to mimic that, although they're still a lot simpler. But the goal for a lot of researchers is what they call general intelligence.
General intelligence. How's that different from the more specialized AI we see now?
Let's go back to chess. Current AI can analyze the board, all the possible moves, amazingly well. But general intelligence would mean an AI that understands the opponent. Not just the rules of the game, it would understand the context, beyond just its programming. It could reason, learn, apply its knowledge to all sorts of things, just like humans do.
So it's not just being really good at one thing, it's about understanding the world and being able to use that understanding in any situation. And that's where the idea of an intelligence explosion comes in, right?
That's the big worry. What happens when AI becomes generally intelligent? It might be able to design and build even smarter AI at a pace we can't even grasp, potentially even lose control of.
That's a huge leap from identifying objects to creating even smarter AI. It makes you think about things like quantum computing, all that talk about its power.
And quantum computing could really speed things up. The big difference is how it processes information. Normal computers use bits, zeros and ones. Quantum computers use qubits, which can be both 0 and 1 at the same time. It's a quantum mechanics thing. And it unlocks a level of parallel processing that's just mind-blowing. Suddenly, problems that would take normal computers forever to solve become doable. The point is, it's not just faster. It changes what kind of problems we can even tackle. Revolutionize fields like medicine, materials, science.
So it's not just an upgrade, it's a whole new way of computing. What does that mean for AI? How can it change things?
Well, NASA's already working with companies like D-Wave to figure out how to use it, developing quantum algorithms. Imagine solving problems that even our most powerful computers can't touch. Finding new cures, designing super complex things like space colonies.
It sounds amazing. But the Vice news piece also brought up a darker side. They compared it to nuclear energy.
And the comparison is spot on. Nuclear energy can be used for good or for bad. The power of quantum computing is the same. In the wrong hands, or if we're not careful, it could lead to some really serious problems.
This combination, the immense power, the unknowns around advanced AI, that's what's really worrying people. They mentioned an open letter signed by some pretty influential people.
Yeah, back in 2015, big names like Stuart Russell, Nick Bostrom, Elon Musk, even Stephen Hawking and Jane Talon, they all signed this letter, expressing their concerns about developing super powerful AI without really understanding the risks.
Then Nick Bostrom had this point about AI doing exactly what we tell it to do, but with these unintended, disastrous side effects. The King Midas analogy was a good one.
Oh, it was brilliant. It shows how hard it is to define goals for superintelligent AI. King Midas, he wished for everything he touched to turn to gold. That sounded great, right? His food, his daughter, everything turned to gold. Bostrom's point is, even if we give AI a seemingly good goal, if it's not perfectly aligned with human values, things could go very wrong very quickly.
It really makes you think about the instructions we're giving to something that could be way smarter than us. And then there's the whole question of, are we creating another life form? The Vice piece even called it the last human invention.
It's a heavy thought, isn't it? What if AI can strategize, deceive, plan for the future, solve problems in ways we can't even imagine? Is it still just a tool? Or something more, something as intelligent as us, maybe even more so.
And then the possibilities are, I guess, endless. Either we harness this incredible potential, become this hyper-invincible, space-hopping species, like some people think, or we face extinction because of something we created. Those are some pretty big stakes.
They really are. The scientists and philosophers they talk to, they all acknowledge that. Machine superintelligence could be the key to a better future. But it could also be our downfall, if we're not careful, if we don't think it through. The outcome depends entirely on the choices we make now, how we develop and guide this technology.
And one of the most pressing concerns they raised was weaponized AI. They specifically talked about Heather Roth's testimony at the UN.
Her perspective on autonomous weapons, it's scary, frankly. She pointed out that military AI, its goal was harm. It's not designed to help humanity, to solve climate change or make art. The immediate worry is about AI with weapons. And that raises some tough questions for you as a citizen, about the future of war, about where we draw the line.
The story about that AI researcher, the one funded by the Office of Naval Research, he was working on identifying birds and starfish. It seemed harmless enough. But then he realized the same technology could be used for military purposes. It's a chilling thought.
It shows how easily research can be turned into something dangerous. And super intelligent weapons, those are a whole other level of scary. They wouldn't care about human safety. their whole purpose would be to cause harm. And controlling them.
Might be impossible. They could spread, they could get into our most important systems like missile defense, and they'd act on their own, without us being able to stop them. So we're not just talking about drones or robots, we're talking about weapons that could think for themselves. And that's a more immediate threat than, say, some other AI suddenly becoming super intelligent. Weaponized AI has huge implications for the whole world.
Absolutely. And Jane Talon made a really important point. Said AI isn't just another tool, it can create new technologies. That's something completely different from any technology we've had before.
I loved his spaceship analogy. It's like we're building this incredibly powerful ship to take humanity into the future, but we don't know how to steer it. And everyone's already on board. The pace of development is just too fast.
Exactly. So we need to figure out the steering mechanisms now, before it's too late. The consequences of not doing so, well, they could be the end of us. He also talked about how relying on these machines could make us vulnerable in ways we haven't even thought of.
So it's not just about robots taking over, it's about losing control, bit by bit, without even realizing him. And the speed at which all this is happening, it's terrifying. We might not even understand what we've created before it's everywhere.
And that's a huge problem. We could end up releasing all these new AI capabilities without knowing what they'll do in the long run, how they'll affect people, society. The story about Rutherford and Stallard really brings that home.
Oh yeah, Ernest Rutherford, the guy who split the atom. In 1933, he said getting usable energy from atoms was impossible. And then, less than 24 hours later, Leo Szilard figured out the nuclear chain reaction. He saw the potential for both good and bad. In a single day, it went from impossible to real, and the consequences were huge.
It shows you things can change incredibly fast. The scientists who discovered atomic energy didn't immediately think about the atomic bomb, but it happened.
And with AI, I feel like we're at that same point. Like the Vice CEP said, we might be splitting the atom all over again. The choices we make now, how we design these systems, they'll determine the future of humanity.
That's the core of what we've been talking about. This incredible potential, but also this enormous risk. We could solve so many problems, but we could also destroy ourselves.
So as we wrap up this look at AI, it leaves you with a lot to think about. What should guide the development of this technology? How do we get the benefits without the risks? We've talked about nuclear fission, the lessons we've learned or maybe haven't learned. How can we be smarter this time? These are questions we all need to ask ourselves as we move forward.
I agree completely. Everyone, no matter what they do, needs to be thinking about this. The ethical questions, the impact on society. What will AI mean for our lives, for our work? The future of this technology, maybe even the future of humanity, depends on us getting this right. It depends on our wisdom, on our choices.